Okay, so let's talk about intermolecular forces and water. So water is a very abundant molecule found on our planet. Our bodies are made up of a lot of water. A lot of the chemistry that we deal with involves water. So water is defined as what's called nature's solvent. And what a solvent is it's the part of the solution that you dissolve something into. So a solution, abbreviated SOL with an N up here, is made up of two parts. It's made up of the solvent that you have more of and the solute that you have less of. So most of the time, the solvent is water, and you're dissolving something into the solvent. And we talked about this a few weeks ago. We said that aqueous solutions are solutions where water is the solvent. So the intermolecular forces and the chemistry of water is really important because a lot of what we're dealing with also involves situations where water is the solvent. So we already know that water is polar, and an important property of water is that water will dissolve ionic compounds. Polar substances dissolve ionic compounds, and the reason for this is something called the ion-dipole interaction. So if you think about it, ions are charged and dipoles is a separation of charge. So ionic compounds can be separated, pulled apart, and surrounded by water. So let's just use salt as an example, table salt. Let's say we have NaCl, and it is a solid, and we put it into a beaker of water. So we're going to put it into a beaker of water. So what happens is when we put that NaCl into water, the positively charged sodium ions are going to separate from the negatively charged chloride ions. And these positive and negatively charged ions are going to be surrounded by water. Remember, water, the positive parts of water are the hydrogens, the negative part of water is the oxygen. So this is going to be surrounded by water with the oxygens facing this positively charged sodium ion. This is called a sphere of hydration. The chlorine ion, because it is negatively charged, the chloride ion, it's going to be surrounded by the positively charged hydrogen ions because they are positive and the chloride ion is negative. So because ions are charged and polar substances have partially positive and partially negative regions, polar substances dissolve ionic compounds. This term is solubility. How soluble something is talks about how likely it is to dissolve. When two liquids are this solubility is like a solid and a liquid. Will this solid dissolve in this liquid? So if it is soluble, then that means it dissolves. If it is not soluble, then it will not dissolve, meaning it will stay solid on the bottom of the beaker. Another term, miscibility, is for two liquids. Is liquids that are soluble in each other. So if they are miscible, then that means they would mix together. If they are immiscible, then they would not. So like oil and water are not miscible. So if you had a container, if you've ever just made salad dressing, you know that the water is separate, or the vinegar, whatever you're using, from the oil. So if this was the oil and this was the water or vinegar, something that's polar, this is polar and this oil is non-polar. Oil and water do not mix because oil is a hydrocarbon. It's made up of a lot of hydrogens and carbons. Hydrocarbons are non-polar and they do not mix with things that are polar. So there's different things you can put in called emulsifying agents that can make your oil and vinegar mix together when you're making salad dressings. But if you just put oil and water or oil and vinegar together in a container, you'll see that they'll separate. That is being called immiscible. So immiscible means that they do not mix. So there's a term that you'll probably hear that says like dissolves like. So polar things will dissolve in polar substances. Non-polar things will dissolve in non-polar substances. So when you're working on this lab, you'll need to determine what is the solute and what you're trying to dissolve. So like dissolves like. So non-polar will mix with non-polar. Polar will mix with polar. But non-polar and polar do not mix. Not miscible, not soluble. So water is polar. So a lot of what happens in biochemistry, the reactions that are happening in our body, this is all based on aqueous solutions where water is the solvent. You also can look at some phase diagrams that I've put in our lecture slide that show the properties of water, how temperature and pressure affect water as we undergo phase transitions. And because of the hydrogen bonding and the size of water, water has some abnormal qualities. One is that water has a higher density. So I'm going to start another little section up here. So properties of water. So one kind of abnormal property of water is that water expands when it freezes. Water has a higher density as a solid. Most other substances have a lower density as they freeze, as it goes from a liquid to solid. Because of the arrangement of the hydrogen bonds in liquid water, when liquid water goes to solid water, the angle increases, the water molecules spread out, so it's the same mass, but it's taking up more volume. This is why ice floats. Ice floats because it has a lower density. I wrote this backward. Water has a lower density as a solid. It has a higher density as a liquid. This is why ice floats. This is really important for life on our planet. Everything that lives in a lake, lakes freeze from the top, so things can still be living in the bottom of the lake. If water had a higher density as a solid, ice would sink and lakes would freeze from the bottom up, and they would freeze the whole way through. There would be no aquatic life in our lakes. Some other important properties of water are surface tension. So because water has especially high intermolecular forces, so these kind of weird properties of water are because of the especially high intermolecular forces, because of its small molecular mass, and because of the hydrogen bonding. So surface tension, I'm sure you all have done that experiment with the penny, where you put drops of water on the penny and you see that the water kind of rounds up on the penny, and it's like the water is forming a bubble. It's because those intermolecular forces are attracting that water to each other. Another is the meniscus of water. The meniscus of water is like this, and it's because water has two forces. So if this was my water in a graduated cylinder, there's cohesion and adhesion. And if you think of the word adhesion, like adhesive, which is glue or things that are stuck together, co means the same, and add means two of different things. So there's two things that is happening here in this meniscus. Cohesion is between the water and the glass, the attractive forces of the water and the glass, which is why the water is kind of rising up the side of that graduated cylinder. Adhesion is between the water and the water. This causes what's called capillary action. So capillary action is another important property of water, where if you take a really small tube, which are normally called capillary tubes, and you touch it to water, water will rush up into that tube. I mean, a tiny tube, like the size of the tip of a pen. Water will rush up into that tube because the water is so attracted to the glass and also to itself. So these are some important properties of water, and this has to do with the strong intermolecular forces. So water as a solvent will dissolve ionic compounds and other polar things. Solubility is a solid with a liquid. Miscibility are two liquids together. And the premise of like dissolves like. Polar things will mix with polar things. Non-polar things will mix with non-polar things. All of this has to do with the intermolecular forces of the molecules.